Hi and welcome to this educational video brought to you by the Society of Mechanical Ventilation. Mandatory Minute Ventilation. MMV.
Hi, today we'll talk about mandatory minute ventilation. Interesting mode, and we'll try to talk about what exactly this mode is, how to set it up, and what some similarities and differences between it and some other modes that might cause confusion, like volume controlled ventilation, SIMV, or even ASV. And also we'll talk a little bit about the advantage and disadvantage of that mode. So when we talk about mandatory minute ventilation, actually that mode was initially described back in the late 70s and further advanced over the last couple of decades. According to Shadburn's classification, that mode is an adaptive closed loop mode that assures minimum minute ventilation, and that's why sometimes it's been referred to as either mandatory minute ventilation or minimum minute ventilation. The mode actually delivers the breath in three different ways according to the patient spontaneous breathing. So if the patient in this area having no spontaneous breathing, like a passive patient, all the breath will be controlled, usually in the volume controlled breath, although there's an option to turn into decelerating flow, which will be basically pressure regulated volume controlled breath. If the patient having some spontaneous breathing but not reaching the set minute ventilation by the clinician, the mode will be basically an SIMV. So some of the breath here will be in pressure support, all triggered by the patient. And if not reaching the minimum minute ventilation, the ventilator will give some controlled modes to reach that minute ventilation. Controlled breath, I'm sorry. But if the patient is all spontaneous and reaching that minimum minute ventilation, all the breath here will be pressure support. So again, volume controlled ventilation if no spontaneous breathing, SIMV if there's partial spontaneous breathing, and full pressure support in full spontaneous breathing patient. Similar slide showing what we just talked about. In this one, the patient has no spontaneous breath. So basically the ventilator gives them the breath in a volume controlled breath. If you notice here, this is a constant flow. This is the airway pressure, looks like a triangle. This is the constant or the square flow waveform, typical of volume controlled modes, and this is the tidal volume. If you notice here, tidal volume is set at 450, respiratory rate of 14, so it gives you minute ventilation of about 6.3, which is here 6.05. All the breaths are mandatory. Now our patients start having some spontaneous breath, and if you notice here, the brown ones are the spontaneous and the blue ones are mandatory breath. So the patient is having some spontaneous, so this is the ventilator gives them an SIMV mode. If you look to the right side here, all the breaths are spontaneous now. So the patient is basically on a pressure support ventilation. He's getting more minute ventilation than the set, 7.23. So the ventilator does not have to give him any mandatory breath. We'll talk a little bit about the mandatory breath in mandatory minute ventilation. Typically, it's supposed to be a volume controlled mode if the patient is not having any spontaneous breath. So again, as we said in the last slide, this is the constant square flow waveform and used in volume controlled modes, and that's the airway pressure. Usually that's a typical, looks like a triangle. But there is an option called auto flow on the ventilator, which is basically pressure regulated volume controlled. So yes, you set the same settings, tidal volume and the respiratory rate, and the ventilator will give the breath in a decelerating flow waveform, typical of pressure controlled modes, again to target the tidal volume that you set here. So if you look here now, you can appreciate the airway pressure looks different from the volume control. the decelerating flow waveform. Again, you can appreciate the difference between here and that's a tidal volume. So still the ventilator will target the same tidal volume, but again in a different flow, resulting in a different airway pressure. So let's talk how are we going to set that mode. If you notice here, it's called volume control mandatory minute ventilation. What's the input that the clinician would put? FiO2, tidal volume, the inspiratory time, sometimes it could be inspiratory to expiratory ratio, I to E ratio, the respiratory rate, the slope, which is the rise time of the inspiratory rise time, the PEEP, and the delta pressure support if the patient is having any spontaneous breathing. And if you notice here, this looks like a pressure controlled waveform because the airway pressure is square, the inspiratory flow is a decelerating one. How do you go back if you want to do it in the volume controlled mode? You go to additional settings. The picture is cut off a little bit here, but there's some other options like automatic tube compensation. Here's off. The auto flow, you can put it on and off. And if you put it on, again, this will be pressure regulated mode. The ventilator will give the breath in the decelerating flow, try to target the tidal volume that you put. But if you turn it off, the ventilator will give the mandatory breath again in the constant flow waveform, typical of volume controlled breath. Of course, there's other options for sigh. The trigger and termination, this is when does the patient have triggered the ventilator. You can, of course, be flow or pressure. Here it's set at 2 liters per minute trigger. And the inspiratory termination, this is usually set at 25% in most of the pressure support modes, but you can adjust this and this will decide when the ventilator cycles from inspiration to expiration, again in the pressure support spontaneous mode.
We'll talk again about the settings, how to set the mandatory minute ventilation. Here we're using a Draeger Infinity C500 with a long simulator, simple simulator to induce spontaneous breathing. Right now the patient is on the volume control and the auto flow is on. That's why again using decelerating flow, and it looks like pressure controlled. So this is basically PRVC. And we'll switch that to mandatory minute ventilation. So we'll go to the settings and we'll choose the choose the VC MMV, FiO2, tidal volume, inspiratory time, respiratory rate, and those will determine the minute ventilation that we will get. Here the auto flow is on, as we talked about, so it looks like airway pressure is squared, decelerating flow waveform, and this is a tidal volume. And the ventilator will try to adjust till we get the mandatory minute ventilation that we dialed. Now we're going to turn off the auto flow to go back to the regular volume controlled mode that MMV usually uses. So you'll notice the difference between the decelerating flow waveform here when he was on auto flow. Now we're going to go to the constant flow square waveform, and you can notice the difference between this and this. And the airway pressure also becomes of a volume controlled. And you'll notice the minute ventilation will start to go up to target the minute ventilation that you dialed. This patient is passive, so no spontaneous breathing. So all the breaths are mandatory breaths. Now we're gonna start bagging, and you'll see spontaneous breath here. The brown ones, the brown are spontaneous, and the blue are the mandatory ones. And we're getting now much higher minute ventilation that we target. So the ventilator does not have to give any mandatory breath. So all of those are in the pressure support mode. We dialed delta pressure of 10 over the PEEP of 8, so the airway pressure will be around 18. Now we're gonna stop having spontaneous breath, so you'll notice that the minute ventilation will start dropping, and the ventilator will sense that and will start going back to the mandatory breath again with the constant flow wave and basically volume controlled. So in the beginning we started as continuous mandatory ventilation. When the patient started breathing, there was basically ASMV, and then we went to pressure support when the patient was triggering all the breaths, and now we were back to mandatory ventilation in the volume controlled mode. So quickly, what's the difference between regular volume controlled mode versus mandatory minute ventilation? And if you look at this slide, this is again volume controlled mode with the square or the constant flow that we talked about and the airway pressure. Here there is a little pause, that's why it looks a little bit different. Versus on that right side, the slide we showed before, again constant flow, there's no pause, so the airway pressure looks like this. The difference in volume control is whether the patient triggers the breath or it's a mandatory breath by the ventilator, all the breaths would look the same. Airway pressure looks the same, the flow looks the same. Versus in mandatory minute ventilation, if the patient is triggering the breath, it will turn into SIMV as we talked before. So this is a quick difference between the volume control and the minute mandatory ventilation. But if the patient has no spontaneous breathing, they will be exactly the same, targeting the same tidal volume respiratory rate that you dialed on. So what's the difference between ASV and MMV? And I heard sometimes talking is, MMV is exactly like ASV, which is not very true. There's some similarities between both modes, but there's also some differences. Before we start, we have a previous lecture about ASV if you're interested to see it. In ASV, the clinician dial the ideal body weight. Basically, you put the height and the gender, and the ventilation determine the ideal body weight. And then you enter the percent minute ventilation. You can go from 25% to up to 350%. But simply put, it's usually 100 milliliter per kg per minute for 100%. So if you put 50%, it will be 50 milliliter per kg. If you put 300%, it will be 300 milliliter per kg per minute. And according to those, the ventilator determines, according to respiratory mechanics with the time constant in the expiratory flow waveform, determines what's the best respiratory rate and tidal volume. So if you look here, the ventilator determined the target minute ventilation, and then based on the Otis equation determine, okay, the best tidal volume is 385, best respiratory rate 22, inspiratory time 1.4, and that's the target. Of course, if the patient is breathing, this might change, so they compare the current with the target, and they give you this graph here to show you that this square, this is like the best target for the patient. The PEEP, the FiO2, the flow trigger, the trigger in general, the inspiratory rise, here it's called P ramp, and the expiratory sensitivity for the spontaneous breathing, you have to enter, the clinician has to enter it. Let's go back to the MMV as we talked about. Yes, you have to enter the minute ventilation, the minimum minute ventilation, but you have to enter it as tidal volume, inspiratory time, and the respiratory rate. So you have to enter that manually. Versus ASV, the ventilator is actually the one determines what's the best according to the respiratory mechanics. So that's one big difference. Of course, you have to enter the PEEP, you have to enter the FiO2, you have to enter the slope or the rise time here, and you have to enter the delta pressure support for the spontaneous breathing. The pressure support for the spontaneous breathing in ASV is also ventilator determined. So I put that table here to just a little bit comparison. So the minute ventilation, yes, there will be minimum minute ventilation, but again here it's clinician determined. You enter the tidal volume respiratory rate versus in ASV you enter the percentage minute ventilation. The controlled breath in MMV is usually volume controlled breath, as we talked about, but if the auto flow option is on, it becomes in a pressure controlled. In ASV, it's always pressure controlled. Now, what happened to the controlled breath if the respiratory mechanics changed? For example, worsening compliance, the same tidal volume and the same respiratory rate. Of course, what will change is the pressure, the airway pressure will increase. In ASV, this is all ventilator determined. So if the respiratory mechanics worse, like for example, compliance worse, actually the target will be different, will change. The respiratory rate might increase, the tidal volume might decrease. How about the inspiratory time? Here in the MMV, it's you have to dial it, clinician dialed, versus in ASV, it's determined again by the respiratory mechanics, so it's ventilator determined. And of course, depending on the respiratory rate, the inspiratory time will change. How about the spontaneous breath, which is the pressure support breath? In MMV, the clinician has to dial the delta pressure support. So every spontaneous breath, it will be in the same pressure support, amount of pressure support, versus in ASV, it will be also ventilator determined, so the pressure support will be variable. The common ones like the PEEP, the FiO2, the rise time, the cycle, they're all have to be clinician determined. So those are some of the different similarities. But again, both modes can be totally controlled if the patient has no breath. They could be like SIMV if the patient is doing partial spontaneous breathing but not achieving the whole minute ventilation here or here. Sorry. And both could be all spontaneous breathing pressure support if the patient is doing all the work and achieving more minute ventilation than the minimum in both modes. So the advantages and disadvantages of MMV in general. And to be honest, I couldn't find much in the literature. Actually, there's not much literature, big studies or good studies about MMV compared to other modes. Lots of the studies I found are in neonates, and some of the studies were old from the 70s when that mode was started. But the question is also like there's small studies about is it faster weaning compared to SIMV? Okay, that's why I put the question mark behind it. But at the same token, we know that studies showed that SIMV might slow the weaning process. Is it more comfortable instead of the patient has more autonomy instead of being always like mandatory ventilation, always the same tidal volume, same airway pressure? Possible that switching between pressure support and SIM and mandatory breath might be more comfortable for the patient. But at the same time, also there's a question of this switch, like in the SIMV, might worsen the work of breathing. So to be totally fair to that mode, I don't know. We don't have any clear evidence that if it's better or worse than other modes.